In this video, I will be teaching you how to solve normal curve problem solving. So let's have a first example of a problem that involves normal curve or normal distribution. So let's have this problem. The mean battery life of a cell phone is 3 years with a standard deviation of 0.32. If you will buy a new cell phone, what is the probability that its battery life will be between 2.5 and 3.2 years? So we have a given mean of 3 years and a standard deviation of 0.32, and we're gonna find the chance or the probability that the one that you have bought has a life between battery life between 2.5 and 3.2 years. So we're gonna convert first this 2.5 and 3.2, which we call it x, into z, because we cannot plot it in the normal curve without changing it into z. So let us transform it using this formula, z equals x minus mean over standard deviation. So we're going to start with the 2.5. So we'll change x by 2.5, the mean with the given 3 years, and the standard deviation 0.32. And then we are going to simplify the top first. 2.5 minus 3 is negative 0.5. Then we'll divide negative 0.5 by 0.32. So it will be approximately equal to negative 1.56. So if the answer is very long, we always round up to 2 decimal places because z value is only up to 2 decimal places based on the z table. So this is the z value for the x equals 2.5. So if x is 3.2, then we're going to find the z is equal to 3.2, that's the x, minus the mean equals 3, and the standard deviation 0.32. Then let us subtract the top. 3.2 minus 3 is 0.2 divided by 0.32, approximately equal to 0.63. So this is the z for 2.5 and for 3.2 years, and we're gonna use this both to solve for the probability using the normal curve. So let us continue. We have find p, or the probability of negative 1.56 less than z less than 0.63. So it means in between negative 1.56 and 0.63. And why is it like this? Because in the problem it's looking for the probability in between 2.5 and 3.2. So the z values of those years are the negative 1.56 and 0.63. So it is in between, and we're gonna find let's have now the normal curve, and let's plot those z values. For negative 1.56, it's here, it's in between negative 1 and 2, so let's put a line or a mark. And for 0.63, it's in between 0 and 1, so it's here, and we'll put the line. Now we're gonna shade the one in the middle because it says in between them. So we're gonna find the area of that. That's the probability that we are looking for. So let's put a line for the center, since our z table is coming from the center, going to the left or going to the right. That's the kind of z table that we're going to use, from 0 to z. And let's find out the 0.63. So from 0 to 0.63, let's find the probability using the z table. So let's locate the row 0.6 and column 0.03. So that's a total of 0.63. So the probability or the area is 2357.2357. Then we're gonna find for the negative 1.56. So we'll find 1.5 and 6 for the column, and so the area is 0.4406. So that's the whole shaded part of that. The left of 0 is 0.4406. And so to find the whole thing, the whole shaded area, we're gonna add the two areas. So the probability of in between negative 1.56 and 0.63 is equal to the 0.4406 plus 0.2357. And those are the areas that we have a while ago. And we're gonna get the sum. The sum is 0.6763. So this means there is 67.63% chance that your new cell phone's battery life will be between 2.5 and 3.2 years. Now let's try another example. So let's have this problem. Fanny wants to be admitted in a certain university, and she knows that she must score better than at least 70% of the students who took the test. She takes a test and scores 430. Will she be admitted to this university? The scores in this test are normally distributed with a mean of 400, standard deviation of 50. So let's analyze this problem. We have a person named Fanny. She wants to join a university, which is not mentioned. Uh, and for her to pass the test, where the total score is not given, uh, her score must be uh, higher than the 70% of the number of takers. So it doesn't matter what is the total score as long as her score will be higher than 70% of the total participants. And so we have a given mean 400, standard deviation of 50. So is the 430 enough to be admitted? And notice that we have a term normally distributed. The scores on this test are normally distributed. So, and also in the previous example where I didn't read it anymore, it must be given because it must be assumed that it's normally distributed, because if it's not normal, if the given is not normally distributed, then we cannot use normal curve. We cannot use z value or z table. So that's why it has to be assumed first that must be a normally distributed data. And so let us convert first the score 430, which is the x, into z so that we can plot it in the normal curve. So I'm going to use the formula for z. So substitute x by 430, and the mean is 400 and standard deviation is 50. Then let us subtract the numerator. 430 minus 400 is 30. Then divide 30 by 50. So z is equal to 0.6. So the x 430, if you transform it into z, it will be 0.6. And we're going to solve now using a normal curve. So let's continue. We're going to find the p of z less than 0.6. So why is this like this? It remember that 0.6 represents the 430, and we want to know the percent that is less than 430. The score is less than 430. So this is why it's lesser than 0.6, because this 0.6 stands for the 430 score. And so let us have now the normal curve, and we're going to plot the 0.6. 0.6 is in between 0 and 1. So of course without the sign means positive 0.6. So it's here, and we're gonna put the line, and then it says less than. So if it says less than, we're gonna shade all the left side of 0.6. And so let's solve now for let's find the area of this shaded part. So let's cut the graph into half so that it's easier for us to use the z table later. And so this part, you don't need to find this because automatic this is 0.5. That's half the curve. So what we need to find is only this part. And we will just add later with the 0.5. So let's use the z table to find the value of that. So it's 0.6. So find the row 0.6. It's here. And then it's only 0.6. There's no next number. It means 0.60. And so we'll use the column 0. And so it means the probability for that, or the area of that part, is 0.2257. So let's have now the probability of z less than 0.6, which is equal to, let's add 0.5 and 0.2257, which will be equal to 0.7257. So this means 72.57% of the examinees got a score below 430. So now let's answer the question. Will she be admitted? So since the requirement is at least 70%, so the answer is yes, she will be admitted. So let's have another example. So we have the average age of a patient who had recovered from the virus is 55 years old, and a standard deviation of 15.8. Assuming that the data is normally distributed and the chance of recovery is higher for younger patients, what is the probability that letter A, a 60-year-old patient will recover from the virus, and letter B, a 20-year-old patient will recover from the virus? And so let's analyze the problem. So by the way, the problems that we have in our examples are just fictitious data, so do not assume that whatever is the result is true in real life. We're just using it for uh, for the sake of showing you how to use the normal curve in solving problems. But these are all fictitious data, not coming from a real data. So let's analyze the problem. The average is given is 55 years old with standard deviation of 15.8. And we want to know if the chance of surviving or recovering for a 60-year-old patient and also for 20-year-old patient. And so let's convert these values into z so that we can use it in our normal curve. So let's use a formula. So for a, z equals x minus mean over standard deviation. So substitute, x is 60 and our mean is 55. So standard deviation is 15.8. Then subtract the numerator, we have 5, and then divide 5 by 15.8. So it will be approximately equal to 0.32. So that 60 will be represented by the z 0.32 in the normal curve. Also for b, we'll substitute 20 minus 55 over 15.8. So 20 minus 55 is negative 35. Then divide by 15.8, approximately equal to negative 2.22. So that age 20 will be represented by negative 2.22 later in the normal curve. So let us continue. Let's find p of z greater than 0.32, where 0.32 is represents the age 60. And we're gonna have now the normal curve. So the normal curve, and we're gonna plot the 0.32 in the normal curve. It's around in between 0 and 1. So it's around here, and we're gonna put a line. And then we are going to shade the probability that we are looking for, or the area that we are looking for. It says find the p of z greater than. So if it's greater than, I'm gonna shade the right side of the graph. Now you might ask, why did I choose greater than instead of less than? So why greater than? It's because it's given that it's assumed that as the patient is younger, then it's gonna be higher recovery chance or chance of recovery. And so if the graph here is if the age of the patient gets higher and higher, so that line will move to the right. So that means the shaded part will get smaller and smaller. So as the age gets higher and higher, then the chance of recovery will be smaller and smaller. So that's the idea of this this symbol greater than. So let's continue. Let's put a line in the middle for that to be easier for us to find the area using a z table. So we're gonna find this area of this part, although this is unshaded from 0 to 0.32, but we're gonna use this to find the area of the shaded part. So let's have the z table. So we're gonna locate 0.32. So we're gonna locate first the row 0.3, so it's here, and 0.02 to make it 0.32. So the area of that unshaded part is 0.1255, and we can now solve for the area of the shaded part, which will be equal to the zero point 0.5, that's the whole thing at the right of 0, and we're gonna remove the unshaded part because that's not part of the answer. So 0.1255, so it will be equal to 0.3745. So this means the chance for a 60-year-old patient to recover from the virus is 37.45%. But of course, this is coming from fictitious data, so this chance is not real. It cannot be applied to the real life, or because you might think that that's only the chance for you to survive if you have a virus. So don't mind the percent, because we are just using a fictitious data just for the sake of applying for our normal curve solution. Now let us solve the B, which is for the 20-year-old patient, where it is represented by the z negative 2.22. So we're going to find the probability of z greater than negative 2.22. Now let's have the normal curve, and we're going to plot the negative 2.22. So it's here, and we'll put a line. And so the shaded part will be this part, the whole thing, because it's greater than the right side. Then we're going to put now the line in the middle. So we know that this part is 0.5, the whole thing at the right of 0. So you don't need to solve that. So, and you just need to add that 0.5 to this part. So the question is, how much is this? So what's the area of this shaded part at the left of 0? So let us use the z table to find the area. So from 0 to negative 2.22. So 2.2, we have this, and then 0.02 to make it all 2.22. So this is an area of 0.4868. So this is 0.4868, and we will just add it with a zero point 0.5. So it will be equal to 0.5 plus 0.4868. So the sum will be 0.9868. So this means the chance for a 20-year-old patient to recover from the virus is 98.68%. So let's continue with another example. We have a large group of students took a test in mathematics, and the final score have a mean of 80 and a standard deviation of 15. If the scores are normally distributed, what percent of the students got a score below 70, that's for A, for B, passed the test given the passing mark is 75, and C got a score between 90 and 100. So we're going to solve all this using a normal curve. So before that, let's convert all these values into z, so that we can just have we can just plot all this in a normal curve later. So let's um, solve first the z values of this given. So our x for a is 70. So we're gonna substitute using this formula. Z equals 70 minus the mean, which is 80. It's given, and the standard deviation is 15. So 70 minus 80 is negative 10, divided by 15. It will be approximately negative 0.67. For B, we have the given x 75. So to substitute, 75 minus 80 divided by 15. So 75 minus 80 is negative 5, divided by 15. So it will be approximately equal to negative 0.33. And for C, there are two x's, 90 and 100. So let's substitute first 90. So 90 minus 80, it will be 10. And then divide by 15. Z is approximately 0.67. And for 100, so let's substitute 100 minus 80, it will be 20. Divided by 15, it will be 1.33 approximately. And we're going to use all these z values in solving for the answer using a normal curve. So let's have the A, find the probability of z less than negative 0.67. So why is it less than? It's because it's given that uh, we're looking for the below 70. So 70 is represented by negative 0.67. And since it says below, so we're going to use less than. And then we're going to plot it in a normal curve. Negative 0.67 is in between 0 and negative 1. So it's here. And then we're going to shade the less than, the left side, because it's less than. So let's put a line also for the middle. And we're going to find this part, because we will use this to find the area of the shaded part. So using the z table, we locate 0.67. So 0.6 and 0.07. It's here. So the area of that unshaded part is 0.2486. So that's unshaded part, so it's not yet the answer. But we're going to use that. So let's find out the probability or the percent. So the whole thing at the left of 0 is 0.5. So that's the unshaded and the shaded part. So we're going to remove the unshaded part, so we'll subtract. So subtract 0.2486. So the difference will be 0.2514. So this means 25.14% of the total number of students got a score below 70. So let's have now the B. Find the P of z greater than negative 0.33. So in this problem, it's looking for the percent of students who got a passing mark, and the passing mark, who passed the test, and the passing mark is 75. So 75 is represented by negative 0.33 as the z value. So you might ask, why greater than? Because the passing mark is 75, then it must be 75 or more. And then why not greater than or equal to? Why just greater than if 75 is part of the pass of those who pass the test? So actually greater than or greater in probability, the result will be the same, because z is equal to negative 0.33 is 0. The probability that z is exactly negative 0.33 is 0. So that's why there's no difference in the result with z greater than negative 0.33 and z greater than or equal to negative 0.33. So there's no difference in the result if it's probability in the normal curve. So no bother about the greater than or equal to and so on. So let's now use the normal curve, and let's substitute. Let's plot the negative 0.33, so it's around here, and then it says greater than, so the shaded part should be at the right side. Then let's put a line in the middle, and to find or to understand what areas are we going to find in the z table. So this is automatically 0.5, so you don't need to find that in the z table. But this part is, we don't know, we're gonna find it. And so let's use the z table, and from 0 to 0.33. So we're gonna locate 0.3, it's here, and 0.03 because it's 0.33. So the area of that part, that strip, is 0.1293. So to find the whole shaded part, we're gonna combine 0.5 and 0.1293. So let's combine 0.5 plus 0.1293. So the sum is 0.6293. So this means 62.93% of the total number of students passed the test. So let us solve now for C. So the C is finding the percent of students who got score of 90, in between 90 and 100. So the same as here in our P, we're going to find the area in between 0.67, that is represented by the score 90, and 1.33, that is represented uh, by the from the score of 100. And so let us plot this in the normal curve. 0.67 is in between 0 and 1. So it's the line. Let's put a line, and then for the z 1.33, so in between 1 and 2. It's around here. So we're looking for in between area. So we're gonna shade the in between part, and let's put now the line for the middle. And so how to find now the area of this strip? So first is we're gonna find this unshaded part, that is 0.67, so 0.6 and 0.007, so that will be an area of 2.2486. That is the unshaded part. Now this part, uh, this is 1.33, so we're gonna find 1.3 and 0.03. That's 1.33. So the area is 0.4082. So that is the unshaded part plus the shaded part. That's the whole thing is 0.4082. And so we just want to, so let's solve this. We want to get only the area of the shaded part. So the whole part 0.4082, we're going to remove the unshaded part 0.2486. So let's subtract that. The result will be 0.1596. So this means 15.96% of the total number of students got a score between 90 and 100. So let's have our last problem. So let's analyze this. The average time of travel from your home to school is 25 minutes and a standard deviation of 5.6 minutes. If your class starts at 8 a.m., what is the probability of not getting late from school if you will leave home at 7:45 in the morning? So we'll assume that the data is normally distributed. And so she observed the given is only the average, which is 25 minutes, or the mean, and standard deviation 5.6 minutes. So there's no given x, or the time that you have traveled from school from home to school. So we're gonna find it. So the x is uh, so how many minutes are you going to travel from 7:45 to 8? So if you leave home 7:45 and your class is 8, so you only have an allowance of 15 minutes of travel. So now that's what we want to find out, if what's the chance with this 15-minute allowance for you not to get late. So we're going to convert this x into z so that we can use it in our normal curve. So the z will be equal to x is 15 minus the mean or the average 25 minutes divided by the standard deviation 5.6. So the z will be 15 minus 25 is negative 10 over 5.6. So the quotient will be negative, approximately negative 1.79. So we're gonna use this representing the x 15 minutes. So the expected answer for this must be it's gonna be lesser chance that you will not get late, because the average travel is 25 minutes and you only have 15 minutes left to go to school. So it must be, the result must be lesser chance of getting late. So we'll see. Let's continue solving. So let us continue solving. We have we're gonna find the p, or the chance of z less than negative 1.79. So why is this like this? Negative 1.79, remember it's representing the 15 minutes allowance for you to go to school from home. And we want to know the chance of not getting late. So for you not to get late, the travel from home to school must be at most 15 or lesser. We want to make it as lesser as you can so that you will not get late. So that's why it's lesser than. So it must be lesser than 15 minutes or equal to. So it must be lesser than the z negative 1.79 or equal to. But as I said before, the lesser or lesser than or equal to are just having the same p or probability. So it doesn't matter because z equals negative 1.79 is just probability equals 0. So it doesn't matter. So let us have now the normal curve, and it's negative 1.79, so it's in between negative 1 and negative 2. It's here. And then it says less than negative 1.79, so we're going to shade at the left side. So let us put now the line for the middle, and we're going to find this because we need this to find the shaded part. So let's use the z table. So let's locate 1.79. So let's start with the 1.7 and then 0.09, so that it's 1.79. So the area of that unshaded part is 0.4633. So that part we're gonna remove that from zero point 0.5. So let us solve now. So the whole thing at the left of 0 is 0 0.5. That's half of the graph. So we're gonna remove the unshaded part, so that what's left is the shaded part. So zero point 0.5 minus 0.4633, it will be 0.0367. So that's the area of the shaded part. So this means your chance of not getting late in your class will be 3.67%. So it's very small chance that you will not get late. Thanks for watching, and I hope you have learned from this video. Please support my channel by pressing the subscribe button, and also write the math topics you want to learn in the comment section.